Okay, so welcome back to Pre-Calculus. We just have one bell work today. Emerson can dig 2 holes in 3 hours. Okay, so we'll say the rate of Emerson is 2 holes in 3 hours, also known as 0.67. Do I really want to do that? I don't know. I don't think maybe I want to do that. I was going to do that, but I don't think I will. And Joanna, no, there's just Jonah. Jonah? Who spells Jonah like that? Anyway, the rate of Jonah is 3 holes in 2 hours. Okay, 6 holes need to be dug. If Emerson digs for 1 hour and then is joined by Jonah, how long will they work together to finish digging the 6 holes? Alright, now let's see here. Alright, so we know there's a time. There's some time. I don't know what it is. Well, I guess I know the first time. Time, I'm going to say the rate. Okay, let me say this first. The holes are going to be equal to the rate, or the rates, times the time, right? Okay. This is analogous to distance is equal to the rate times time. Okay. So anyway, if we say, for instance, as an example, if we said holes were equal to, we'll say 3 holes per hour. Somebody's really fast here, and they worked for 2 hours. Boy, that's beautiful. Beautiful work there. They worked for 2 hours. The hours are going to cancel, and I'm going to be left with holes. 3 times 2 is 6 holes. So if it was just one rate, I'd know it would take 2 hours if somebody dug that fast, which nobody's digging that fast. Apparently these are big holes. So anyway, what we're going to do here is we're going to lay it out like this. We're going to say, we know that there has to be 6 holes. Okay, so that's not in doubt. And that's going to equal Emerson's rate times 1 hour. So I'm going to say R sub E, times time, sub 1, I guess. I don't know. Is that too fancy? Plus, I know that rate times time is holes. So there's the first part of the holes. And then the second part of the holes is there's a second time that Emerson works times the second time where they're both working, right? They're both working the second time. And when I add it all up, I get 6 holes. And notice that when I multiply by time, then the hours cancel. The hours on the bottom, up here, the hours cancel, right? So no more hours, so just holes. Okay, so let's plug in some things. We're going to say the rate of Emerson is 2 holes per 3 hours. And then it's going to be 1 hour, right? 1 hour, whatever. Plus, the rate of Emerson again is 2 over 3. You get the idea, so I don't need to use the units anymore. Times T sub 2 plus 3 over 2 times T sub 2. Okay, so now let's see what we have. We have 2 over 3, so we have 2/3 of a hole, plus, it's common denominator time, right? So, let's see, times 2 on the bottom, right? Where are we here? Times 2 on the bottom, times 2 on the top, times 3 on the bottom, times 3 on the top. And we will say 4 over 6 T2 plus 9 over 6 T2. Okay, so we can combine those now. And we will say 6. We assume that it's all about wholes now. 2/3 plus, we combine these and we get 13 over 6 T2. Alright, so I'm going to subtract my 2/3 from this side. Let's see, if I wanted a common denominator, I would say 18 minus 2 is 16 over 3 is equal to 13 over 6 T2. You see this? Okay, so I subtracted 2/3 from both sides. 2/3 from both sides. And now I want the T2 alone because I want to know, how long will they work together to finish digging the 6 holes? That's the T2 that I'm finding. So I'm going to multiply by 6 over 13 on both sides. And a little bit cancels. The 3 and the 6 cancel. And this is an alternate ending from what I had before. 2 times 16 is 32 over 13 is equal to, well, the 6's cancel and the 13's cancel, and I have T2. So T2 is a little bit more than 2 hours. So I would say 13 goes into 32 twice, and then how much is left over? About 6. So 6, and if we wanted to really get a sense of how long, this is a fine answer. I like improper fractions, but that's how many hours